Hello everyone, welcome back. In the last session, we saw the topics in the data structure and algorithm. In this session, we're gonna see the introduction of the data structure and algorithm. What is data structure? Why it's so used? So, data structure, meaning of this word lies in this word itself. Data structure, data which is structured. Why it's need to be kept in a particular order? Why it shouldn't be in random order? So, I will give you one example. In the kitchen, there will be shelf. In that shelf, we'll keep the different jars. In that jar, there will be different ingredients, right? In small boxes. So in some kitchens, they will keep it in order. In some kitchen, they don't. So what's the use of keeping it in order? So they can find it easily. So if they don't, they normally have to open it and see which ingredients this and keep it there. Again, they have to get the another jar and open it and see it. If they keep it in order, so okay, they know it. They take it easily while making a dish, and simply they can see and put it. So else what happens is they have to keep on looking for their required ingredients. So there's a one example. I'll give you another example of a library. So we'll go to the library. You wanted a book of a data structure and algorithm of a particular author. So you'll go enter the library. What we'll do? You will see there is a different racks. Maybe there are different racks divided into different branches: computer science, electronics, civil, mechanical, so on. There is a different branches and general section also there. So there will be a different section, right? In that section, you need a data structure and algorithm. You go to computer science and algorithm section, and in that rack you search for it. There is a subsections, right? There is a subsection of subjects. Okay, you will find the you required subject, right? I mean, you will find the data structure and algorithm book section. So we'll go to that data structure and algorithm section, and you'll find there is a different authors there in that section. So you'll find your author, whichever author you want. You will take that book and come. Okay. So what else in the library they don't kept it in order? How you'll find it? Yeah, you can find it. I think you need much more time than previous example. I mean, if there is no order, okay, if there is no order, you need a much time to find a book. So that's what helpful. That's the example of real time. Here we're talking about the computer or a device which has a processor and a memory. So standard definition for the data structure and algorithm is data is arranged in such a way that it can used efficiently. So in the example I told of library, in the library, if you want to find the book, so if it's in order, you can find it easily. If it's not in order, so it's it will take a very much time to find the book. So that's the importance of a data structure. What is algorithm? So algorithm is nothing but the rules for the data structure. The data structure can be represented in a different way. It can arrange in a different ways. I'll go back to the library example. I told there will be a books which is kept in a different section in different arrangement, right? It can be it can be kept in other order also. Like it can be put in alphabetic order, or it can put it in arranged in like that in semester wise. So it can be arranged a different way also. So algorithm also helpful for the data, like it can be arranged in some such a way that it can use it efficiently. So also it can perform a different operation on a data. So we can use it depending on we can insert the data or delete the data or display data, or so many operations are there. We're gonna cover it in the upcoming session. So this algorithm is also called abstract data type. ADT. This algorithm also called abstract data type. So let's take a real-time example. So here is an array of the number. So there is a 6 element in this array. So each contains a different address, maybe 2046, 2050, 2054, 2058, 2062, 2066. So I have taken a size of the integer is 4 byte. So it may be 2 bytes also, depending on the compiler size. So this is the memory block with the 6 element. So what we need to do is we need to find this element. I mean which index section the number is present. So how we're gonna find it? So directly we can say 3 is in first section, right? First index. So normally human can do that. So but computer can't work like that. I mean it won't work like that. So what we'll do is we'll write a program. So we write a program for a for loop for I is equal to 0, I less than n. N is the size of this array. So I plus plus. So what we'll do is if a of I is equal to number is nothing but this 3. So if we find this a of I means in the first iteration I will be 0. So a of 0 is equal to is 3. First is 3. So this a of 3 is equal to number is nothing but 3. So if this number is equal to 3, then print number is found on %d place I. So its number is found in a particular index. So in the first iteration a of 0 is nothing but 1 is equal to 3. Is it right? No. So we'll go to next iteration. I is equal to 1. A of 1 is equal to 3. So in second iteration 3 is equal to 3. Is this condition is right? Yes. So it will go to inside this if loop section. So in here it will be print number is found on the %d. %d is nothing but I. So number is found on the first place. I mean this first index, right? So this is the one way to find the number. So there is we can perform it in a different way. I'll show you another way. So let's say there is a 6 element in this array. So what we'll do is we'll divide this array into 2 sections. So n by 2, that is 6 elements are there. 6 by 2 is equal to 3. Index number 3. What is the number in the index number? It's 8. So computer know that the number 3 which we are finding is there in the left side of this array. It's not in this right side of the array, right? So computer will know that it's in the left side. So it will go this side itself, it won't go this side, right? So once again it will see the left side of array and it will divide the this array. So how many elements? There are 3 elements. What is the middle element of that? It's nothing but 1. So it will check with that element. So is that element is equal to number? Yes, it's equal to number. So its condition is true, so that it can print the answer. It's in a number. It's in a first index of that array. So this is how we can perform a different operation on the array. So there may be so many techniques we're gonna study how we can perform the operation on the different types of data. So I'll go to a real-time example of a library. So what if what if there's no order, right? It will take much more time. Let's say there is a 100 book. How much time you need? Maybe 1 hour. Okay, let's say 1 hour. So what if there is a 500 books? 5 hours. Okay. What if there's 1,000 books? Don't know. What if 10,000 books, or maybe more than that? It will take more time, right? So as there is a less book, it will take less time, right? So for this concept, there is a concept of time complexity, and another one is a space complexity. So these are the very two important topics in data structure. We'll see it in the next section in detail. So times complexity and space complexity. So that's it for this video. I hope you enjoyed this video. If you like this video, if you feel this video is worth watching, please hit the subscribe button. If you like this video, please hit the like button. If you have any comments, please put it in a comment section, and we'll see you in the next section. Thank you so much.